we have 9x squared minus 49. There's two ways you can do this one. One way is you can put a 0x in the middle of it and factor it as 9x squared plus 0x minus 49. And then you can factor like normal. The other way you can do this one is recognize that 9 is a perfect square, x squared is a perfect square, and 49 is a perfect square. So these are all perfect squares. If you recognize the perfect squares and it's a subtraction, then you can just say, okay, well, it's a difference of squares. And so you just take the square root of all of them, and it's 3x minus 7 and 3x plus 7. Okay. If you want to do it the other way, we take 9 times 49, and 9 times 49 gives us negative 441. 441 happens to be a perfect square. It's 21 times 21, and since it's negative, I have to have a negative 21 and a positive 21 to equal to 0. So then I have 9x squared minus 21x plus 21x minus 49, and then we factor by grouping. We take out a 3x, and that leaves us with 3x minus 7. And then here we take out a 7, and I take out a positive 7 because I have plus minus, so the negative signs are in the same position. It makes a pattern. And so then we get, 3x minus 7. And so notice I've got the two 3x minus 7s that factor out into one thing, so that's 3x minus 7. And my other factors are 3x plus 7 that go together, and notice you get the same answer. So you can do that one either way. Okay, number 20. This one is also supposed to have a square on the middle term, so that's a typo. So I check for common factors. I have two 6's here, but 5 is not divisible by 6, so there's no common factors. So we got to multiply the first and the last, and that gives us negative 36. And so what multiplies to 36? That adds to give me 5. And of course that would be 9 and 4. And I have a positive number here, so the smaller number is the negative one. So I have 6x to the 4th plus 9x squared minus 4x squared minus 6. Then we factor out by grouping. This one I can take out a 3x squared, and that leaves me with 2x squared plus 3. And then this one I can factor out a 2, and these are both negative. Anytime they're both negative, you factor out a negative. So take out a negative 2, and that gives me 2x plus 3, and it changes to plus because when you take out a negative and you divide, negative divided by negative makes it positive. And so then what's in our parentheses is the same. So that's our new common factor, and it factors out 2x squared plus 3 is our first factor. And then our second one is what's left over, 3x squared minus 2. And that's our final answer. Now, number 21. we have 10n squared plus 100n plus 250. I check for a common factor, and they're all divisible by 10. So I take out a 10, and that leaves me with n squared plus 10n plus 25. And now I've got a 1 in front of my number here. All right, so now we multiply the first and the last. 1 times 25 is 25. So what multiplies to 25? That adds to equal 10. Of course, that's 5 and 5. So we keep our 10 out here. Since I have a 1 in front, I don't have to go through the grouping process. I can just put it in n plus 5. And notice it's going to be another n plus 5, so I can just write n plus 5 squared. All right, 22. We have 10p cubed minus 1960p. Notice they're both divisible by 10 and they both have a p, so I can factor out a 10p, and that gives me p squared minus 196. So then I have to check to see if this factors more, and it does because this is a difference of two squares. So I keep my 10p out here, and then the difference of squares is a lot like the one that we just did for number 19, where you can just, if you recognize it as a difference of two squares, you can just go ahead and split it into your two different ones. Otherwise, you put the 0 inside and then multiply and do the process like we do for every other problem. Since this one is a difference of two squares, it's going to be p plus 14 and p minus 14. And neither of those factor anymore. So then I box in my answer and we're done with the problem.